All right, greetings everyone. Welcome to the first part of the video for section 8.2. Moving on in chapter 8, looking at a concept now that at first may not seem like it's directly related to trigonometry, but I promise it is. And just so you know, this will be a little bit different probably than anything you've learned in math up to this point, but maybe not, depending on your background. All right, we're going to start talking about something called polar coordinates. So polar coordinates are a different way of plotting points in a coordinate plane. Now, up to this point, probably most of the graphing that you have done or plotting of points has been in what is called the Cartesian coordinate system. And usually that consists of x and y's, but not always. So when we're looking at polar coordinates now, instead of having a point as, say, an x comma a y, we're still going to have an ordered pair, but this time it's going to be an r comma a theta. And we can think of r and theta in the way that we've been thinking about them this whole class. So r being a radius, a distance from the origin on a coordinate axis, and then theta being an angle rotation that we measure from starting in standard position. Okay, so let's look at some examples of this. And there on the right in this picture, you'll see that I have a copy of, again, what we call the Cartesian coordinate system, which is the one that we are most familiar with. And on the left there, I have what is called the polar coordinate system. Okay, and you can see how they're a little bit different, but you also hopefully see how it's related to what I was just talking about on the previous slide. So when we plot points in polar, we go out a certain distance, a radius distance out from the origin, and then we rotate around some angle, theta. I have some points here that we'll look at doing this with. So let's look at the first one. So we have 3 and pi over 6. And remember that the order these go in are r comma theta. So 3 pi over 6 tells us that we're going to go out 3 units from the origin. So out 1, 2, 3. And then rotate around a measure of pi over 6 radians, which we know is about 30 degrees. And looking at the coordinate axis here, I believe this would be 45 degrees, which I think makes this 30 degrees. And oh, good, Cody, you're not doing a bad example by not doing these in radians. Sorry. This would be pi over 4. This would be pi over 6, and then pi over 3 here. And so we go from measuring in standard position, which again means that we start there on the positive part of the horizontal axis. And now we're going to rotate around pi over 6 radians. And the place where we end, not there though, place where we end here, that would be our point. So right there. So that green point there, that would be the point 3 comma pi over 6 in polar coordinates. Now it turns out, and sometimes it's helpful, we can still actually plot these points in the Cartesian coordinate system. We just have to use the same kind of idea. So we start from the origin, go out 3 units since our r value is 3. And then we'll rotate around pi over 6 radians, which we know is about 30 degrees. So maybe about somewhere to here. And then we could plot our point. Okay, and hopefully see connections between how I did that and how I did it on the polar coordinates. Okay. All right, let's do the next one. So we have 2 comma negative pi over 4. So again, doing this on the polar coordinates grid, we have a radius of 2, which means we go out 2 units. And then we rotate negative pi over 4 radians, which remember when we rotate negative angles, that means we go clockwise. And that means it's pi over 4, so it's about 45 degrees, or exactly 45 degrees. And so we get this blue dot in this case there. All right. So this one's blue. This one is green. And again, we could plot that point over here on the Cartesian axis. Again, we go out 2 units this time, and then rotate around about pi over 4 radians, 45 degrees, and we end up right here. Okay, so that blue one there would be our next point. All right, now for the last one, we have -3 and 5 pi over 3. And we'll deal with the -3 here in a second. So I'm actually going to start by just thinking about rotating around 5 pi over 3 radians, which if I start from the horizontal, the positive part of the horizontal axis, say here, 5 pi over 3 I know is around in the 4th quadrant, so maybe right about here. And then, let me highlight that, right about here. So around like this. And then in this case, the radius is -3. And in the problems we have been doing, if it was like, say, a distance of 3, we would start at the origin, go out 1, 2, 3 units, right? 1, 2, 3, like that. But in this case, it's -3, which actually tells us to go the opposite way, right? Instead of coming out in the positive direction, we would go out in the negative, which I think would make us end up 1, 2, 3 here. And so our point would end up being here in the upper left. All right. And over here in the Cartesian coordinate, excuse me, it would look something like, say, this point here. All right. Okay, that's it for now. Thank you for watching.